I'm Dr. Cody Nemunitis, Sea Grant Weather and Climate Extension Specialist at the National Severe Storms Laboratory and the Cooperative Institute for Mesoscale Meteorological Studies at the University of Oklahoma. In this video, I'll be discussing the impacts of climate change on the water cycle. The water cycle describes how water evaporates from the surface of the Earth, rises into the atmosphere, cools and condenses into rain or snow in clouds, and falls again to the surface as precipitation. The water falling on land collects in rivers, lakes, soil, and porous layers of rock. Much of the water flows back into the oceans where it will once more evaporate. The cycling of water in and out of the atmosphere has a significant impact on the weather patterns across the Earth. Climate change is altering the water cycle by affecting where, when, and how much water is available. As the atmosphere warms, evaporation rates will increase, resulting in increased amounts of moisture circulating throughout the lower atmosphere. In addition, warmer air can hold more water vapor. The result of higher water vapor concentrations is the increased intensity of precipitation. During heavy precipitation events, much of the water runs off into the rivers and streams, leading to increased flooding. Annual average precipitation over the continental United States as a whole increased by close to 2 inches between 1895 and 2011. The number and intensity of heavy precipitation events have increased significantly and are projected to increase in all regions of the United States. Increased evaporation rates also accelerate the drying of the land surface, increasing the incidence and severity of drought. Surface drying decreases the amount of water moving downward through the layers of the soil, resulting in decreased groundwater recharge. The length of both short-term and long-term droughts is projected to increase, especially in the southern United States. As a result, communities may be susceptible to reduced water supplies. Warmer temperatures will also cause more precipitation to fall as rain rather than snow. An earlier arrival of spring-like conditions leads to earlier peaks in snowmelt and resulting river flows. In areas dependent on the gradual melting of snowpack to supply surface water through the warm months, this means seasons with the highest water demand, typically summer and fall, are impacted by a reduced availability of fresh water. Increased temperatures are also directly linked to a rise in global sea levels. Global sea level has risen by approximately 8 inches since reliable record-keeping began in 1880. It is projected to rise another 1 to 4 feet by 2100. Like mercury in a thermometer, water expands as it warms up, causing sea levels to rise. This process is called thermal expansion. The increased melting of glaciers and ice sheets, or land-based ice, is also contributing to sea level rise at increasing rates. The melting of sea ice, however, does not contribute to the sea level rise. The effects of climate change on the water cycle will significantly impact water resource management. Increased intensity of precipitation may stress dams, wastewater treatment plants, storm drains, levees, and flood prevention infrastructure. Drought conditions may reduce surface water levels, allow for saltwater intrusion in coastal locations, and threaten drinking water supplies. Coastal hospitals, schools, transportation facilities, and wastewater treatment plants may become temporarily inundated due to flooding and storm surge, or permanently inundated due to sea level rise. Buildings may be damaged or destroyed by extreme weather events, storm surge, and sea level rise. As a result, climate adaptation planning has focused on the strengthening of water resource management and improving infrastructure. Best management practices include green roofs, less water-intensive landscaping ordinances, water restrictions, alternative paving products, enhanced erosion management, gray water reuse, and storm-resistant building codes. In extreme cases, adaptation may mean community relocation. Finally, international arrangements need to be considered in managing water resources that cross national boundaries, such as the Colorado River and Rio Grande, when planning for future climate change. The water cycle is a global system, and changes in the water cycle due to increasing greenhouse gas concentrations in the atmosphere will have global impacts. Management, planning, and adaptation strategies are complex and must involve interactions between a variety of different sectors, regions, and nations.